What is an angle? Well, the first thing to know is an angle is formed when two lines meet. So we can see on the screen I've got a vertical red line and a horizontal red line, and they meet to form a point. And whenever those two lines meet to form a point, they also form an angle, shown here with that orange curve. That is the angle that we are measuring. An angle is a measure of turn, and we measure it in degrees. So this here says 90 degrees, and it's 90 degrees of turn. And what that means is, were I to drag this line down so they were on top of each other, so we've got 0 degrees, so they're the same line, there's no angle. Were I then to raise up the second line, the amount of turn that the line has undergone from 0 to here is 26 degrees of turn. It's turned 26 degrees around that point where they meet. We should be familiar with the idea of 90 degrees being a kind of quarter turn. We can then move in to 180 degrees, which is that half turn, so it's halfway round the point, which is that central point, and 360 degrees as a full turn. So where that line, as we can see, it's gone all the way from its starting place through 90 degrees of turn, through 180 degrees of turn or a half turn, through 3/4 of a turn, all the way back to its starting place, 360 degrees of turn. So to recap then, an angle is formed where two lines meet. Usually we would use, in this case it's an orange line, we'd use a curve to show the angle that we're measuring. An angle is a measure of turn, and we use degrees. When we're measuring length, we might use centimetres. When we're measuring angles, we're using degrees. And this angle on the screen at the moment is 90 degrees. Let's have a look at some types of angle. In your work today, you're going to focus on 3 different types of angles. I'm going to talk through each, and I'm going to talk about 2 other kinds of angles as well. The first kind of angle we're going to talk about is an acute angle. An acute angle is any degree of turn between 0 degrees all the way up to 89 degrees. So any of these angles, that would be an acute angle at 54 degrees, at 21 degrees, at 8 degrees. Any of these angles is an acute angle. And in fact, I have a handy bit on the side here to show. So acute, acute, acute. Anything from 0 up to 89. Once we get to 90 degrees, and you'll see on the side, we've got a right angle. Very familiar, has that kind of familiar L shape, and it's also the one where we often use our fingers and our thumbs, to make the shape of, to help us remember. It's a right angle. A right angle is only at 90 degrees. If we go to 89, we're into acute territory, and if we go past 90, we get into that third type of angle, which is an obtuse angle. Obtuse angles run from 91 degrees all the way through to 179 degrees. So let's recap that from the start. So watching the angle on the screen, we can see we've got acute, 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 90 degrees, right angle, obtuse, 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 all the way to 179 degrees. Those are our 3 types of angle we're focusing on today. Acute, a right angle, and obtuse. past obtuse, if we go to 180 degrees, we have got a straight angle. That's what this website is calling it. I would just call it a straight line, and we can see that's a straight line because it looks straight. So 180 degrees is a straight line. But those of you who are good with your doubling, you'll have noticed that 90 degrees is a right angle, 2 lots of 90 degrees, so 2 90-degree turns is 180 degrees, which makes a half turn a straight line. For those year 4s moving into year 5 territory, once we go past 180 degrees, we actually move into reflex angles. So these are angles which are more than 180, but less than a whole turn. And you can see there, we've still got that orange line showing the degree of turn. We're measuring around the outside of where 2 lines are meeting. That might be an exterior angle. If we were to measure the interior angle, well, the interior angle would be acute. But you don't need to know that for today's activities. And it would be a reflex angle all the way up to 360 degrees, which would be a whole turn, or a full angle they've called it here. I haven't asked you to use numbers and degrees to figure out whether something is an acute angle or an obtuse angle or a right angle today. I'm asking you to use your eyes to notice when it is in the area of being acute or in the area of being obtuse or a right angle. Now, mostly that could be done visibly by sight. For example, here, if I didn't have it having 45 degrees there, I could see it was acute because of its shape. And it has that shape where the 2 lines, the angle between them is quite close together. 90 degrees is that nice L shape, and an obtuse is one which is sort of, I always think of it as a fat angle. It's got a really big space between the 2 lines. The degree of turn is quite big. Now, what you have to remember here is that angles are not always pointing in the same direction. So I'm going to show you some examples. So at the moment on the screen we've got 90 degrees, but I could have 90 degrees pointing in this direction. It's still 90 degrees because the degree, the amount of turn is the same, but it's facing a different direction. And in fact, I can make 90 degrees in lots of different ways. So it doesn't have to be facing in one direction. It would be a mistake to think that 90-degree angles are only those which look like that. That's not what a right angle is. A right angle is a 90-degree turn between the 2 lines, and that could be facing that way, kind of an arrow pointing down. It could be the opposite way. It could be facing that way. It could be facing all kinds of different ways. Okay, that's the same for acute and obtuse angles. If I can get, there we go. So an acute angle could face that way, or it could equally be facing that way. It could be pointing, almost pointing down, it could be pointing up. All of these, as we can see, are acute angles. And a part of what recognising these angles is just having that idea of the kind of standard acute angle and what it looks like, and applying it in a different context so that you're aware. So it's just using that basic idea of that's kind of what an acute angle looks like. Well, I've now got an angle over here. Well, if I turn my paper and I turned it round, it looks like an acute angle. So that's a top tip. And of course, it doesn't really need to be said, the same works for obtuse. You could have them any which way and it can still be obtuse. So don't get caught out by that today. Angles do not have to be in a set direction. They can be any kind of direction, depending on how those lines are drawn. If I were to be ordering angles in terms of size, then acute angles are the smaller angles, and an acute angle where the two lines are closest to each other is the smaller. So in this case, this is an acute angle, this is an acute angle. The smaller one would be this one, because the two lines are closer to each other. 90 degrees is bigger than any acute angle, and an obtuse angle is bigger than 90 degrees. So you can kind of think of acute angles as the smaller angles. The more open your angle is, so the further apart those lines seem to be, the bigger the space between the two lines, the bigger the angle is, until you all get all the way to 180 degrees for your straight line. Small angles, smaller, smaller, getting bigger, bigger, as they open up. One of your tasks today involves identifying angles in 2D shapes, so I'm going to talk you through this example, which is a pentagon. Now, as you know, we've got 3 different types of angle we're looking at today. We've got right angles, acute angles, and obtuse angles, and it might help you, like me, to have those pictures nearby. As a reference, we know already that we might need to do some turning, but they can still be helpful for knowing what kind of angles we've got at a glance. My second piece of advice for you is to, much like we saw on the website, to mark out the angles that you're looking at. We know an angle is formed when 2 lines meet, so wherever 2 lines meet, I might draw a curve to join them, because then I know what angles I'm looking at. For your activity, you're only looking for internal angles. So that means angles inside the shape. I'm not interested in these angles. That is an angle, it's a reflex angle, but they're not the kind of angles I'm interested in for your work today, so don't worry about those. We're focused on these internal angles, which I've marked in orange. Straight away, I've identified, or I'm looking at, this angle on the bottom here. It looks like one of my little pictures, and it looks like an obtuse angle, so I know that's an obtuse, so I might put a little O there. The other angles, they might be harder to tell, and they're harder to tell because they are not facing the same direction. They might look 90, this one up the top looks like it might be 90 degrees, it can be hard to tell. So my top piece of advice to you is to rotate, turn these things around. So what I'm going to do very quickly is add a dot. I'm going to put it as a red dot, and I'm going to put that dot here, so I know that's what I'm looking at. And I'm going to rotate this pentagon until it's around to the bottom. Now, of course, I've thrown all of my other curves and things out of shape, but by rotating it around, if I just get rid of my notes there, if I quickly erase those, I can see now that that angle that I saw before, that I thought could have been 90, this angle here, well, now I've turned it, it looks exactly like the obtuse angle, so that must be an obtuse angle too. Ah. And you could do this with all of those angles, all those internal angles for these shapes. Keep turning it until it looks like something familiar to you, whether it looks 90 or looks obtuse or looks acute. That's a top tip for you. It should see you right. It's also a really good tip for when you're doing exam papers or any other kind of test involving angles and shape. You're allowed to turn the bits of paper around. Always do it. It's helpful. It means you make less mistakes, or fewer mistakes, I should say. Another top tip that I have for you is to use an angle finder. An angle finder, which I've included in something you can print off and cut out. It works best with tracing paper, but I know a lot of people don't have tracing paper at home. Is essentially a 90-degree angle that I've got here. I've made mine a bit transparent to help me out. It's 90 degrees. I know that if the lines are on, if the angle, when I measure it over the top, if the line is on this side, then it's acute. If it's on this side, it's obtuse. And if it's straight up and it matches perfectly, then I've got a 90-degree angle. So that's what that is for. And if I do it here, let me move it over. All I do is, I've got that horizontal red line, I've got the vertical red line, I match up the horizontal one, and I match up the points. Ooh, I match up the points of the two lines that I'm looking at. There we go. So matching the 2 points over the top, I can see they're matched along here. I've got the 2 points matched up here, and the line on the pentagon goes on the left of the right angle line in red, so it's an obtuse angle. Nice and straightforward. If I were to have, let's quickly draw another. So if I had a rectangle here, feel a bit nice and blue there, and I were to take my angle finder, again I do the same thing. I match them in the corner, so I've lined up the bottom edge, bottom side. I can see it's a 90 degrees, they perfectly match. In terms of an acute angle, you would see it on this side here. So when you're identifying angles and shapes, you could use an angle finder, which is a 90-degree angle that you can use as a reference to help you.